you should do this. Right, it's better do that. Don't fuck with them backups. Me Santiago, I got my path. Right, you should do this. What's up, guys? Today I'm gonna talk about how I am reverse engineering Twitter. Okay, so let me tell you about my setup. So I've got a rooted Android emulator. I installed a custom CA on this. I installed the Twitter app. I installed a really old version because I think that one doesn't have SSL pinning, and I use this article. With it. The only thing I used from this article was this JavaScript script and these two commands. Yeah, this one. It's helpful. Anyway, and so basically what SSL pinning is how I bypass SSL pinning is I made the phone think that it had trusted certificate authorities installed on it, but it was just my certificate. Yeah, right. And basically that allowed me to intercept the request. And so this is just a request from the login screen. I didn't even enter credentials yet. And the goal here isn't to just make a functioning Twitter client. The goal here is to like analyze each request and find out how each request was generated. So yeah, it's not the same objective as some of the other people. So I'm still doing I just finished the first request, and this took like a day to make, a day to figure out. It was mostly just random data though. Anyway, right, mysterious strings. I'm using Notion to keep track of everything I do. Right, and so you see I took each header and I made an entire thing of how it was generated, how it was made, the code in the actual app that generated the strings. Right. And then I also did this Postman thing, and you could basically rerun the request yourself and see the answers. So for example, you see using this data, the authorization is hard-coded into the app. Device ID, UUID, client ad ID, trace ID, they're all randomly generated. And but you still get the same bearer token. So if you look here and you look at our intercepted requests, right, you get the same bearer. W82F. What else am I using? Right, so as I said, I deep dove into the source code of the app and I copied snippets. I told you how the strings were generated. So actually, let me show you the code. So I use an online tool. I forgot what it was, but you can do this offline, obviously. Also, part of the project is making a free and open source Twitter client, Twitter front end. So right. And so in this sources folder, you can get everything. So for example, if I cd re sources, sources, and let's look at how client no, never mind, that's too hard. Let's look at how right, so the red ones mean that I fully figured this out. The green ones mean I did not fully figure this out yet, and I'm just using a randomly generated number. Right, this looks easy. So in sources, P000 FLF. So let me just cd P000 Never mind. Oh, there's a lot of fucking files over there. Great, let's crash it. So if I open up FLF, you can see here, oh, right here. And so it uses a map to put in headers. I guess that makes sense. So yeah, it says string B equals to C1, and then when you go here and you look for the C1315T class file, and then you find that this is a function which generates a random hexadecimal digit, and what you pass in is the amount of characters. And so how did I figure out that what you pass in is the amount of characters? Well, I could have looked at the code of it, but I like to overcomplicate things. So if you look at our XB3 trace ID, oh no, it's in the request. If you look at our XB3 trace ID, it's actually 64 bits because each number takes up 4 bits because that's how hex works, and 64 bit divided by 4, 16 numbers, and they're randomly generated, so we just make our own. Actually, let me run the only request, the first request that I figured out for you. If I run this, bam, I get the bearer token. Now this is practically worthless, but I think this first request that I decoded, it laid out a lot of the groundwork, and I think the next ones are gonna be way faster to figure out. That's it. Thank you.